you again to please complete the survey in the app after the session is finished. And if you would like a copy of the content following the session, you can come right up to the front here, scan your badge, and you'll get a copy of that. And now I would like to welcome to the stage Shazli Mohammed Ghazali, presenting on Failure is Not an Option, Designing Highly Resilient AWS Systems.
Hi. Good afternoon, everybody. How was lunch? Okay? If you are still eating, please continue and bring your food in the hall, and we'll start soon. So today we're going to talk about failure is not an option, designing highly available AWS system. So in today's world, we have many types of workloads, but one of the things users are not willing to accept our failures. So in the sense that while we need to design everything so that it can be uptime as much as possible. So what we're going to talk about, what are we planning for? Risk and resiliency requirements, think resiliency, principles of resiliency and resilient design, how to assess operation and patterns and best practices. Because it's not just about an infrastructure that is resilient, there are cultures, there are practices so that your whole infrastructure, your whole workload, your whole culture is based on highly resilient practices. So basically, this is our CTO, Werner Vocals. He says everything fails all the time. But the topic is failure is not option. So how does this work? So in a sense of what we have is that things happen all the time, and we need to think about how to address all these failures if and when it happens. Okay. So here, resiliency. Resiliency is the ability for a system to recover quickly and continue even when a failure occurs. So in terms of resiliency, it's not just a matter of having the system up all the time. If something does happen, how do you recover from it? How do you get in as little time as possible? So we will cover a bit more detail how to do this. Okay. So in terms of why happen, so if IT failures lead to broad society impact. So in terms like government services, if you want to pay your citizen taxes, parking, and if something happens and you can't pay your duly taxes on time, it will lead to a lot of problems. It will lead to an organization not to be impacted in terms of availability, interservicity, in terms of SLA to your end users. So this will happen in a broad range of industries. Airlines, if you want to book ticket and then you don't get the tickets is one, then you start to go to the airline and start to complain. Financial institutions, communications, these are all things that will be impacted drastically if an IT failure happens. Okay. So point number 2 is mainly related to point number 1. More and more people depend on IT systems for everything. So not only for your end users, internally you are reliant on IT infrastructure for your own daily tasks. So if you want to have things like if you want to update your order book, if you want to do data entry, these things are now very much like highly dependent on IT systems. If that happens, and one of the key reasons is that you are not productive, you will not get your value, and monetarily you may not get the your income as much as possible. So either time for people dependent on system, lost productivity, time of putting out fires and recovering, and loss of revenue. So people, if it's down, what's going to happen? If you're in the shop, then you're going to say, oh, it's closed until for 5 minutes, and then in 5 minutes it's going to be closed for another 5 minutes. So you don't want to do that for your end customers. Time putting out fires and recovering. If you're an operations guy, chances are this is what you would be doing most of the time. There's always something failure, there's always something that needs to be fixed, and you just want to keep the lights on in the office. Okay? Loss of revenue from the system, so your business will be impacted in that sense. So, in a sense, what are we planning for? So in terms of disasters, not all disasters are created equal. Okay? So if you have this, probably something small, this is to represent things like a smaller failure. So in terms of a smaller failure, a recovery strategy would just be to do a restoration of a previous backup. If the data is small, it may take like a couple of minutes. If the data is larger, it may take more time. So this could be some sort of a preliminary step of recovery with a small failure. Okay? How about this? What happens with this? If a larger scale event happens, so things like different components, multiple components start to fail, what would you need to do about it? Okay, you may need to do some sort of data replication, some sort of switch over of systems, things to recover from this sort of events happening. Okay, all this happens. If you are in a geographical risk area and there's a natural disaster that happens, what would you do? It might not be a smaller component localized within one location. Even the whole location, is not there anymore. So how would you actually recover from that? Okay, so things might be, like different regions or different data centers for you to recover from. Okay, so with this, so that's when we cater for these failures, different type of failures, you cater it differently, all right? So in terms of how we cater it is based on tiers. So if you go from the lower tier up to the highest tier, there are differences in terms of recovery time, there are differences in terms of monetary costs, and then there are differences in implementation methods. So such as backup restores, if you can afford the restoration in days for some system, then you can just recover it. Maybe it's just a media sharing site, which, if it's not there, your business will not be impacted, and you can afford that sort of downtime. Or it goes all the way to pilot light, where you have a smaller scale infrastructure waiting for something to happen, or if you have a warm standby, just pilot, just waiting for an event to happen, all the way up to multi-site active, where you have different infrastructure in 2 different places or multiple places, each having its own workload running continuously, waiting for something to, without waiting. They're just production. If something goes down, then it's okay because you already catered for that. And of course, monetary-wise, backup restore, maybe it's just a couple of storage space. Multi-site active, then you have different components, different replication methods for you to cater for in terms of architecture. Okay? So basically what this is, so this old adage, if you want to stay alive, you make sure you are faster than the slowest guy there. So what we want to do is not to penalize the slowest guy, is that we need to help everyone to be at the same page. So basically, at least the bad would not know which one to choose from. So what you need to do is you need to cater for all the lowest link in your chain, and make sure that all that is all resilient, and make sure that they are able to handle faults, right? So some of the causes of failures, very much the most common is operator error, manual operator errors. Okay, if you are using the Unix world or Linux world, if you just sometimes you do just CD to different directory, then something happens, and it has happened before. Sometimes they just go to the directory and they just do remove star, and then suddenly, oh, how come my system is down? It's because you actually deleted everything, so that's not a good thing to do, right? So so in terms of what are the probability happens, it may happen, the probability is higher than most of having operators errors. Deployment induced, so when you are moving from production to staging to development, there are some things where you may not have considered in terms of the networking configuration. Maybe you have to put in a different subnet. In terms of what the deployment is, how you want to, the deployment files, how you want to configure it inside the production environment, those things, the probability are higher there. Load induced, if it's like a very large scale event, if there's an F1 race and then everyone wants to see what happened, who will go on the race, then the system will just be, hopefully it be scaled, designed to be scaled for that large event to happen. And then there are some things like data induced, some of the poison pills happen, credential expiration. So if you have one system that actually needs to talk to another system, chances are you need some sort of authentication to have there. And most of the time with security policies, you have set an expiration date. So once the expiration date is expired, then you will say, oh, how come my web server doesn't talk to a database server? So those are the things which you need to occur. In terms of hardware and infrastructure, those are things that rarely go down. Or if it go down, there are built-in mechanisms to cater for all these different faults. So we need to know what are the risks of things happening and how serious are they to happen. On-premise data center realities. So if you maintain your own data center, you are well aware, especially with regulatory and government and finance institutions, there will be regular DR tests. So inside, for this weekend, we will need to perform a test, swing over to DR, and then you need to stay over and see and just make sure everything's running. And then there are things like connected to the internet, exposed to same external attacks. So if you are having, even if it's on on-premise data center, if you still have web servers that is running there, you are still opening yourself to all different types of security attacks or different types of network utilizations, such as if you have a high load that's introduced inside your web application. DR side is always active. If there's a disaster or no disaster, you're still paying for a data center there. Maybe it's a lower cost, but there is still a sunken cost there where you need to pay for a disaster site. Data is constantly replicated, so basically it's the network bandwidth is there, and data center security is expensive and resource intensive. So basically these sort of things where you need to actually consider with on-premise data centers. We'll just talk a bit about the principles of resiliency. So if you want to so I say I want to make my system more resilient. What are the pillars that I need to follow and adhere to? So this is basically what are some of the pillars of resiliency in the 21st century. Test recovery procedures. So if anything happens, if a failure happens, you need to test it out. Just not make it as a documentation, and then if it happens, we just try it out and see what happens. So that's not really the way to go. Automatically recover from failure. So the key word is automatic. If you are requiring a manual process, if you need someone to come into the office and recover from the failure, that would not be an ideal situation. Scale horizontally to improve availability. So you want your system to scale up. So just like the race that's happened, if something happens, you want it to automatically scale out. You don't want it to size your infrastructure at a peak. Because then you have all these wasted resources that you are paying for, but you're not actually utilized until there's one or two events happening. Okay, which leads to the last one, stop guessing capacity. So you don't pay for what you don't use. You don't need to guess what is your maximum utilization. Let the system handle it, and it will actually use those resources for you. And manage range to automation. If something does happen, if there is a system outage, if there is, if one of the resources fails, automatically the system is supposed to recover from you, be it like you to replace it or just to kill it and replace with a newer version of that resource. Okay? Okay. What do those 9s really means? Okay, so these are availabilities numbers that you've seen before. In terms of SLAs, even for you to get services from a vendor, they'll ask how many 9s do you have. So these things are So this is just a chart to see what those means. So if you have 99%, that means in a year you're having less than 3 days downtime, and then max disruption is about 14 minutes. With 5 9s or even 4 9s, you have 52 minutes in a year, and then max disruption about 8 seconds in a month. And some organizations, these are directly impacted to your KPI. So there's some, I know organizations where if your system is down for more than 30 minutes, your bonus is all gone for that year. So this is a key thing that's happened, and not only for an organization, but even from your back-to-back agreement from yourself or your organization to your own end users. So these are quite important numbers for you to consider. Okay? So, we've know what is resiliency. Now we need to know how to cater for it and how to measure what sort of resilient point or some metrics for you to size your solution to cater for resiliency. So there are 2 points. There's the recovery point objective, RPO, and recovery time objective, which is RTO. So RPO is the amount of time where you are willing to accept the data loss. Let's say a failure happens. How much days of data or hours of data are you willing to lose in an acceptable fashion so that my system can still continue as designed? So if I'm willing to accept that I may lose 1 day of data, then I will put my RPO as 1 day. Okay. And then there's RTO. So RTO is how much time where you will need to recover from the system. So if my web server has failed, what is the time that I need to bring it up and make sure that the service is up again? So if it says it's 1 hour, then that will be your RTO time. And of course, with any users, what will be your wish list for an RPO and RTO? Most of the time will be as close to 0 as possible, right? But as we saw earlier, there are different risks, and then there are different impacts of business impacts, which actually caters and defines what is your RPO and RTO time, right? So you control how you manage your own risks. So when you have your business, inside your business level, you are measuring what the risks are, businessing risks, your sourcing risks, what your technology risks. If something happens, what the risk of effects that I'm willing to cover and willing to accept if a failure happens. In terms of compliance, what sort of compliance I need to adhere to if for a failure to happen. Customer provided and managed control, so all your policies, your organization security policies, what you need to adhere to, things like operations, things like risk management, what is stated in your organization for you to follow as a part of your organization. And then technology-wise, so things like virtual private cloud, key management, logging, so things how you are managing your cloud infrastructure there. Okay. So this, in terms of responsibility, it is the customer's responsibility, but of course we can help in terms of how you cater for some of the things such as the tools to ensure of your resiliency. Okay. And AWS, what we manage, so in terms of what we provide to you is we provide all the managed and audited controls. So in terms of our global infrastructure, we actually provide all the security, resiliency, the audited controls, and what are the standards that AWS complies to. So with this, you can see this is basically the shared responsibility model, where AWS and the customers will actually share responsibility for ensuring the resiliency operations of your organization, of your environment, right? Okay, so we've talked about the principle of it. Let's start to design what, in terms of resiliency, how do you design that? Okay, so this is Gall's law. Gall's law says a complex system that works is very found to have evolved from a simple system that works. So basically, you don't nowadays you don't start with something big and then make that to be your. You start off with something like a big mega structure to start off. You start off with simple system workloads and mesh it up and build it up like Lego blocks into something more complex and more complete. Okay. So it's not binary. You start somewhere and scale up. So basically, you do not need to start fresh. You can start from people who have been in the business a while and can help you to achieve your resilient goals. Okay, so in AWS you say there is no compression algorithm for experiences. So in terms of where we are, we've been in the business for 13 years. We have grown, we have experienced many things, some good, some bad, but all of them are learning experiences to make all our services to be much more resilient and much resilient and compliant for all of our users. Okay, so we have the experience to build the world's reliable, secure, scalable, and cost-effective infrastructure. Your operation DNA has to be crafted for reliability. So Once you have your SLA, then you need to make sure what you have to determine what sort of SLA you want to achieve with your infrastructure, whether it wants to be 99% or 100% availability. So in terms of S3, so you see that there's many nines, it's actually 11 nines of durability. So for this sort of storage, you can ensure that you can get your data fairly availability and durable to achieve any type of disasters. Availability zones where you where different geographical region or your data centers are separated in terms of fault lines and floodplains. Okay, so again, so disaster happens, but how do you ensure availability? Mainly with automation and redundancy. Okay. So a bit about our global infrastructure. We have 23 regions and 67 availability zones, 2 Gov clouds in the United States with new regions coming out, with new government cloud and new secret regions coming up. Okay, so the latest region was online was Bahrain. We still have Jakarta and Milan and Cape Town to be coming up online soon. So in terms of as a user, you think of it as you have a whole world of data centers for you to choose from. You're not just relying on data centers which are local or you have to build yourself or purchase yourself. You can actually choose any type of region across the world in all continents except for Antarctica. All right. In terms of connectivity options, we have many 96 direct connect locations. You can reach every region except for China. We have multiple edge location, Amazon CloudFront point of presence, and also direct connect locations. So in terms of our infrastructure of connectivity is our own high-speed line between different regions and even within the regions between the multiple AZs. Okay, so in terms of if you want to scale up and you have businesses that you want to quickly scale worldwide, we have our point of presence location like CloudFront to inside a close in a location closest to you. So even if your region is not there, you can still have a local presence there for you to ensure availability for your customers. Okay. So in terms of the infrastructure, we talked about it. So we have regions and availability zones. We have cell-based architecture. So in terms of our different services like S3, like DynamoDB, like Lambda, these are all little modules which you can actually build and assemble together to become something even more complete. Multi-AZ architecture. So an availability zone is a location with one or more data centers inside there. If you want to ensure availability, you can have one infrastructure in one availability zone and another availability zone. So you actually cater for different locations to ensure service is always online. Microservices architecture. So in terms of if you have a big monolithic infrastructure, you want to break down different services, like e-payment will be one services, data bases, data mining, data analytics will be different services. So these things you can actually subdivide and segregate so that you know the failure for one will not affect the others. So your blast radius will be smaller. And distribution system for best practices. So here we need to understand what are the AZs and what are the considerations to have whether you want to have different regions or different availability zones there. Networking, like I said, we have different high-speed networking infrastructure. If you're going for a hybrid architecture, then you want to have the connection between your data center to AWS to be highly available. So with multiple direct connect location, you can have multiple like active, passive, or active kind of connection into the AWS from connecting to different direct connect location. So with the networking sorted out, we see data. So you should have constant resiliency of data. There are many forms of data that's there. We have things like EBS or block storage, databases, and in-memory cache. And these different services handle resiliency a bit different from each other. For example, with RDS or database instances, you can have a multi-AZ where you can have an active and a secondary database inside different availability zones. If you want to have a different region, you can have a different replica in different regions. So basically, it's only a read-only database, but if you want to have something that is standby, and then or you want to do some business analytics on without actually affecting your primary database, then you can have the read replicas there. In terms of our object store, we have S3 cost region application. So if you have a lot of media files, if you have a lot of object of files that you want to store and you want to make that highly available, you can actually have this with different regions replicated to different regions. Okay. Self-healing applications, highly resilient application must be able to self-heal. So you leverage microservices app architecture. So in terms of what you can have is that, with our services like load balancer and auto scaling group and SQS, you can have your infrastructure such as an EC2 instance to be scaled out with an auto scaling group, all being balanced by the load balancer in terms of spreading the workload between these different EC2 instances. So if one EC2 fail, then let it fail, we'll just start up another one. And then if you've been to other technologies, they give the analogy of pets versus cattle. You don't really treat your service as something that you need to take care of properly. If something happens to it, let it expire and just start a new service there. All right. System architecture blueprint. So now we have the building blocks of all these different items. Now you want to put it together. I come from the solution architects world. So basically, how we can help you to do is to architect so that you can have the most resilient infrastructure in a more timely fashion if required. But these are the things where you start to put things together and become one complete service. So in terms of the first, we have a single region or multi-AZ. Start here before adopting more complex architecture. So in terms of what you can have now, if you want to have some sort of within region availability, you can put it inside one availability zone and put the other workload inside another availability zone. So just now when we talked about load balancer, auto scaling group, databases which are active passive which can recover on another availability zone, you can actually start off with here. Okay. Next is an active standby backup environment used in event of failure only. So in terms of this, what you may want to have is maybe your policy says I need to have another infrastructure in another region. So you can have an active passive standby in one region. So your prime region is active. Only if a disaster happens, then you shoot up and start up all the services and have it active on the second region. So there are pros and cons, mainly in terms of latency delays while standby becomes active. So basically, you're doing a cold start of your DR infrastructure to serve your users there. So the RPO limited by replication lag. So these are services that are involved. Route 53 is our DNS service where you can actually configure Route 53 to load balance the workload to different regions based on availability. Right? Then we have things like active. So both stacks are active at a time and the traffic is distributed. Basically, you are spreading the workload at between multiple regions. So with Route 53, you can also configure that so that your workload is spread out between different regions there. In terms of data replication, you need to have this data to be in sync, all the time. So you have to be multiple committed at the same time. So we have our partners solutions that can help you that. So things like Cloud Endure, disaster recovery, itinerary replicate, and when this go, NetApp allows it to actually sync this different storages together so that they'll be checkpoint and will be synchronized. Okay. Multi-region dual write, so share nothing application. So this is mainly if you have a traditional infrastructure where you cannot do much with it. So what you do is you actually have different workloads moving at different regions. So if something happens, then you can actually fail over. You can actually have this workload to be failed over to the other side. So what happens is that you need to have some sort of facility to checkpoint and reconcile jobs between these two regions when required. Okay. Some anti-patterns, so basically replicate on-premise problems and patterns to the cloud. So basically you should not treat your cloud, the way you treat it in the cloud is a bit different from your on-premise data infrastructure. The use of non-redundant architecture to meet schedules, single data center architecture, so you should not have the single data center to be utilized all the time. Reusing manual processes. So like what we say, if you're doing manual processes, the chances of failure or it to happen is very much higher. So you should automate as much as possible, responding to monitor alerts and metrics as soon as possible. Okay. So basically, don't sacrifice long-term values for short-term results. Okay. So in terms of operations, you've already set up your infrastructure, you already set up your blueprint, how to make your operations, because operation is a key pillar. So if you want to have a successful operation, you need to have a successful, consistent implementation of change, have insights to operation health. So basically, you need to know what your system is doing all the time, all right? So how is doing things like operation as code? So you code how you to cater for resources. So things like operations monitoring, you must detect failure fast. With CloudWatch, you can actually log the trend or what activities is happening with your cloud, and you can automate the responses from there. Okay, automation. Basically, you can do things like have cloud formation to automatically to create the infrastructure for you. So rather than having you to manually go and configure all your components, CloudFormation can actually do all this infrastructure setup as code. So that's why you have infrastructure as code there. Okay. Application deployment. So what you have is that one of the other sources of failure is actually moving things from development to production. So some things you may have left some sort of parameters we need to go into production environment. So you can have this all CI/CD pipeline where you have blue-green deployments. Test it out on a couple of services on resources first, and then once it's okay, then you roll out to the rest of your environment. So we have a large products to support the CI/CD pipeline like code build and code deploy to support this effective deployment mechanism. Testing enforces resiliency. How do you know that you are resilient or not? So inside one of the previous summit, so it says chaos doesn't cause problems, it reveals them. So if something happens to your system, at least you know that there's something you need to cater and address if something happens, right? So there are things like application testing and certification. So you have different methods to see what happens to a failure and how does it affect your business. Okay, there are things. So that's why we have a failure mode effect analysis. There are some other practices like BIA or business impact analysis for them. Okay, so in terms of failure of an AZ, then you know what would the effect be. Okay, so chaos engineering, this is something which where you actually do and introduce failures inside your environment. So somebody will actually purposely do and stop a service. Somebody will actually purposely like remove a disk and see how your system will react to that. So this is based on chaos engineering. So if you hear of Chaos Monkey, things like the Simian Army, then you can. So these are the practices which has been utilized by some of our larger customers, so such as Netflix and things. Okay. So we have continuous testing of infrastructure. So you regularly execute tests in stable production and production-like test environment. So you will actually need to make sure enforce regularly that you test that things fail. So some of the practices have is like game days. So let's say, today we'll just remove an EC2 instance. We turn off the security group and we do other things, and then we'll see what happens. And if there's something you need to address, you can actually address it because you've planned for it, all right? So you can do it when you do CI/CD testing and then infrastructure to build pipeline. So we've covered a lot of things so far, but all different system all behaves differently, and you will architect it differently. So the way you would design an application for one company or one department would not be the same from another one. So it is something that we need to architect of course, we can start off with template, but ultimately we need to architect it and give consideration differently and specific to your use case. With AWS, we have solution architects that can actually help you to architect for this. There are things we follow some best practices that to ensure for have your system to be resilient there. So future considerations, so consider serverless. If you want to not manage servers anymore, things go to serverless such as Lambda so that you don't have to worry about infrastructure or worry about patching. Take advantage of distributed systems such as S3 for object store with our 11.9 availability, Lambda and ECS. Break down systems into smaller pieces along logical lines to reduce the blast radius, so things about microservices there. Well-architected tools, so basically we have a well-architected framework where we follow our own best practices based on our long-term experience to have availability in cloud based on 5 pillars, and having resiliency is one of them. So with that, I'd like to say thank you for spending some time with me, and please complete the survey and have a nice day. Thank you so much.
Thank you, Shazli. And yes, please complete that survey. I did find out that everyone can redeem an AWS swag item at the info desk where the Ask the Expert zone is. So please complete that and present that to get your swag. Also, if you would like the slides, make sure you scan your badge at the front right here with the content team. And in a few minutes, we will have the implementing a data warehouse on AWS session that will begin at 1:45. Thank you.